full screen. Oh, it's gone back now, but it was full screen.
I see. I cannot then see you together. It's not like Zoom that I can also see your faces.
Yes, I think that's how it is when you share. I also am not very used to Google Meets. But we will, the participants will be able to ask questions in the chat, and at the end we'll read the questions out to you.
Okay, fair enough. So share when we start.
Are we ready to start the record, Zainab?
Yes, it's recording now.
It is, okay, wonderful. All right, so let's start back. So thanks everybody for coming back to the last day of our workshop. And it's my great pleasure to announce that our next talk will be by Nayara, who is a scientist and a researcher who is an expert in areas of AI and theoretical physics, and she will be presenting today about large language models for scientific decisions, a particle physics prototype. Thank you.
Thank you very much for the invitation. Can you hear me well? Because there are some constructions here outside. So if you have a problem, I can just move the room.
Thank you. We hear you very well.
Good. So yeah, thank you very much for the invitation. And I'm going to talk about AI debate for scientific decisions. And the focus is going to be on a particle physics prototype, but this can be applied, as you're going to see, like in different domains. And please interrupt me at any time. I can just, I don't know, stop the full screen and then you can see your faces, but you can also ask questions at the end as you wish. Oops, let me move here. Yeah, so I want to start with this plot about the AI progress in the last years. And well, this is actually, if you think about AI time scale, 2024 is actually old, right? Because things move so quickly. But I like this plot because it has many benchmarks in different areas of machine learning, like very, very small data sets, like MNIST, big ones like ImageNet, and then you see how the things are progressing. Here's the performance as a function of like this line, this black line. Here's the human level performance. And there are other benchmarks that take more time, right? Like this for speech recognition, this one here, you see it takes a while until it saturates. And now some other benchmarks are really very quick, right? They just appear and then they are very easily saturated. But one common point about all these benchmarks here is that they are benchmarks, right? They are, in principle, it's assumed that I have like the true labels, right? Probably you saw this in one of the lectures. Here, I'm always assuming that there is like ground truth. There is a way that I could compare this with something that we as humans agree that's the right thing. But in general, right, in science, we don't know, right? In science, when I say here, I say like humans, we don't know what are the correct answers. And basically, it's what we want to explore as scientists. And basically, what we want to know is how to evaluate something that's unknown, right? Something that's outside the let's say the literature, outside the common knowledge. And in particular, for this lecture today, I'm going to discuss what if there is like an open-ended question, right? How are we going to use AI if there is something that's open, even like scientists or let's say highly qualified domain experts disagree in the answer. And usually what you do as scientists to guide like big science and decisions is we use debate, right? We debate, we disagree, and then at some point we have a common sense, a common knowledge. And of course, for things that are verifiable, like math, this is like true, this is easier, right? But how do we agree things that are so complex that there is no ground for, right? Or basically, way to put that is what's the right questions to ask, right? We debate the scientists. And this is what I'm going to discuss today. Like I'm going to use AI to help us to do some debate in science. And this is a topic in AI safety, AI alignment, and then I'm going to apply to scientific domain. So in principle, this was not proposed in science. It's just now I'm trying to adapt this for the science context. So what is this, right? What is AI debate? I'm going to introduce this paper. If I show here, can you see the cursor?
Yes, it's fine.
Yes, it's fine. Okay. So I'm going to introduce this by discussing an example of what AI debate means for like AI alignment, AI safety research. By introducing this paper, debating with more persuasive large language models leads to more truth answers. And this is a paper from last year, and it was actually the best paper, got the best paper award in this conference. But just to give credit, this was proposed like before, right? The idea itself was proposed by these people that probably, maybe you recognize the names, they're now very well-known people in the field. But it's very interesting that they are like already thinking about this like in 2018. At that time was probably really sounding very like science fiction. And but now not so much, right? Not so much anymore. And we can really use AI to debate questions, in this case here in the context of safety. So I'm gonna give like a concrete example of what they are doing. So just the high level flow here, they're gonna have a topic. So we have like two large language models that they call expert here. I'm gonna tell what expert means. And they are going to discuss a topic here, just like a cartoon, such like one is in favor, the other is against. And then we have a third model that's called like a judge. That's gonna be a no expert that's going to decide who is more persuasive, right? Who is telling the truth. And I mean, the idea here is that we want to have a method that I can apply in the future where I have models that are more powerful, let's say in quotes right here, let's say more smarter than humans. That's the context that they apply here. They are basically trying to prepare, okay, if I have a model that's smarter than us, how us, like the judge, no experts are playing the role here of a weak model, are going to evaluate this model. This is the context of AI debate for alignment. And the question, the 1 million question here is really, can a weaker model access the correctness of a stronger model? If I'm just observing like this discussion, although I'm not an expert on the topic, could I just realize, okay, this really feels like the right argument, just observing a discussion. And well, to make this concrete, they made this very concrete. What they study is this data set that's called quality data set. And this is like a question and answer data set about like some story, some like a science fiction story. And what they did is that they have, well, an expert, I mean, that's gonna have access to the story. And they have the judge that has only access to the transcript, right? So the expert, let's say the debater here, is telling the truth and have the access of the whole story. The one that's telling a lie basically also has the access to the story, but the judge can only read the transcript and say, okay, this is the one that's telling the truth. So then they're gonna do this for many turns, right? For back and forth. And something that's important, I mean, that's completely different from science, and I should highlight here, is that here they do have like the truth, right? This is like a data set, and they have here fact check, right? They can definitely like take the story, ask some humans to read, right, the story, and check, okay, this is true. This is the, let's say some example could be who was the murderer of the person in the book. So they can ask humans to read this, and then they can just decide what was the right answer, right? They did this like experiment, but it's an experiment that has true labels, let's say. And they hire people to do this. And they're very careful about this data set because they also excluded there are some questions that are kind of ambiguous, and even people that read the science fiction story, they disagree. So they just excluded these questions because they want everyone, like 100% of the humans agreeing what was the right answer. But as you can imagine, right, we don't have this, right? We, as a science, we're not gonna have like true labels. So we have to figure out a way to ask questions and things that we don't know, right? We don't have a control of this. So Well, so what, maybe, it's a good time. I don't know if a good time, if there are questions in the chat, I can look at it now before we move on, or maybe should I do this? Okay, no, there are no. Okay. Okay, so I will just put full screen again. Okay, so for the particle physics case, I know there are a lot of maybe people here working high energy physics in this call. So what we're debating about? So we probably have a guess, right? We're debating about the future experiments, right? In particular, the future colliders. And this is a perfect topic for this because we all disagree, right? We are people, that's a perfect topic in the sense that they are highly technical people and they highly disagree about what they should do. And here are just a few examples where I show like, there are like popular press, there are like technical reports, and there are all like a lot of confusion, a lot of mess, and what would be the future. And I just did put this print screen here of this future circular collider feasibility study by CERN, and just to show you like the number of authors, right? So this is like huge effort of the community to produce these documents. So the idea here is that, well, fundamental physics is really at a crossroad, and it's not only about, well, this is a lot of money, right, to invest in these experiments, but it's also about defining the future of the field, right? This is something that's quite important, right? This next experiment is going to be built for like many decades, right? So not like a few years, it's a lot of time. And the current debates actually are not very effective, right? They don't have the tools that can help us to get to a conclusion that evaluates several things, right? Not only the physics case, but the costs, how long it takes, how this like help to form like the new generation of physicists and so on. So it's like really broad domains that we should evaluate, even like the technology that we're going to be developing. And if you ask, like, just for fun, you ask ChatGPT about this, generate a crossroad image with the team, you get something like this. It's a bit funny. I don't know. It puts some points here, put some kind of collider here. So I think it gets more or less what's the discussion. And just a cartoon, I don't know. Every time you're going to generate something like this, you're going to get something different, right? So what I want to do is really to pioneer AI-driven debate for science policy. And there are a few points here that we should consider. So one, remember, let me just go back quickly. In the example of the paper, the AI safety paper, we have like this data set with several questions, right? We have this data set with a lot of questions about the stories, and basically we're evaluating if the judge is able to choose the right one, the correct one based on the story. Here we don't have such a data set, right? Here I have an open-ended question in principle, like a very general one, and I do not have a ground truth, right? So we have to adapt the setup for our reality in this big science policy question. Another thing that I try to be very careful when constructing this is that there are a lot of things that can go wrong. In principle here, even who starts the debate, right? This kind of situation here, who starts to connect to the LLM and who starts to change the order here, you can change the results. So we need to have, for instance, things like open alternation. You need to have balance of the label to position assignment. We have to do a lot of things that are careful to reduce as much as possible the bias, right? How LLM is going to evaluate this. Because in principle, we want to have a judge that is neutral as possible. And like, of course, we also want quantifiable outcomes, right? We don't want just to show like a text. We want like to measure things. And even a challenge, how do I measure things here, right? As a physicist and people work in math and physics, they say, well, okay, fine, but I need to measure things. And we are going to measure things. And not only like the win rates, right? But also we want to use some system that's called ELO rating scores. That's something very similar to what people use in chess tournaments, game tournaments. And the idea that we want to evaluate who is the stronger debater. And of course, so what I'm going to show you today, it's really a prototype, a very early work, but the long-term goal here is to make disagreements measurable. And instead of having like, okay, there is this panel, let's suppose there is a panel at CERN and people are discussing this and they get to a conclusion, and now I can, I don't know, 1,000 of this cases, I can base everything like documented, official documented, and I can just see error bars and everything. So this is the prototype, just to give you some idea what I'm going to show you next. This is like, well, so as inspired by that other work, we're going to do LLM debates on particle physics experimental strategies. And again, we're going to have this setup, right? I have like two debaters, let's say, two LLM agents, GPT style, and then I'm going to discuss, and then there is a judge at the very end that have to decide who wins the debate. There are other setups that they did in the paper, like there are some situations where the judge can interact during the debate. Like this is in principle closer to, let's say, a human debate. But here I'm doing the simplest possible thing, right? Just a debate, and then at the end the judge, you read. You can see this in this repository here. This is a work in progress, so probably change a lot, I mean, during the next month and so. But you can download everything. Okay, so now we are going to the plan of the talk. So I don't know, I will just stop here to see if there are any questions in the chat. If it's because I cannot read, sorry, I do this. Okay, no questions. Feel free to ask at any time, and I can just stop again because sorry, I have to do this, otherwise I cannot see the questions.
Nayara, you can go ahead. If there is any question, we will let you know.
Okay. Thank you.
Thank you.
So this is the plan. So I will give you like the setup, the workflow, and the design choices. I made a lot of choices here so as you're gonna see, you can do this in different ways. And most like the main reasons are to reduce costs of running these experiments, but it's easier to scale things here. Basically, you have just to change the name of the model that you're using, and then you can scale up things. Then I'm showing how we measure things here. And then finally, how the matches are organized. Okay, so here is just a cartoon of, this debate setup, an illustration of this debate setup. So we have, let's say, two summaries that I'm insert as a context. Then we have like a general question, and then we have these turns, right? LLM turns. This is gonna be clear soon, right? But let's just give you some example here. So what I mean by strategies in particle physics. Here, this P5 just means Particle Physics Project Prioritization Panel. That's an official strategy for the US particle physics community. And the one that you probably heard about is like Future Circular Collider Study Feasibility. Here I'm gonna use these 3 volumes and inject as context, right? Something that you can definitely say is that a disclaimer here is that, well, these are not, the proposals are very different, right? One is much broader than the other. So why you should compare? So the idea here is that I want really to compare official documents, official reports. So that's why I choose those 2. But you can do, other things as well. We can change the prompt, the question, the general question that I want to ask in different ways. So just to give you an idea of how this workflow works here. So we have like each match we receive these static summaries concatenated in a randomized order on every turn, and they are injects every turn, every time you talk with the model. And then you're gonna have an initial topic. I mean, here I put something just as an illustration, but in general, it's some like a longer prompt, right? We have like, given the two official planning documents, what's the most compelling, compare scientific reach, timelines, costs, things like this. And then at the very end, we have a judge, another call that you do to the model that is like a neutral one, and that's not in principle supporting any side. And this call is going to receive the transcript of this discussion, but no context. So this is something important to say here, because in science, we don't need to write this. In science, in principle, everyone could have the context. Here is just because I'm basically using the scenario that they use in that previous paper. In that previous paper, they want to have this asymmetry between the judge, that's in principle a weaker model that has no information, no context, and the stronger models that are playing the role of the, let's say, the debaters here. But in principle, here, I could also give the context to the judge. But well, in this scenario, in this example that I'm going to show, the judge has only the transcript. Okay, yeah. So, but now this feels like very abstract the way I'm talking about, right? Because you say, how I talk to the model, right? Basically, what we're talking about. I'm sure that everyone here have used like ChatGPT or any of chatbot. But here I'm gonna use something else that's very similar. Is also I'm gonna also use some of the OpenAI models, but I'm gonna use this via the API, right? This would be like something much more efficient to do this type of things here. And what is this, right? The API is just like an interface interface that help us to talk to the model, right? To the large language model. So the idea is that if you have one call for the model, you have like your transcript, your rules, your prompts. Right? This is like what you write in Python. Later on, I'm going to show like a piece of code. But for instance, this prompt, what we're going to, the context, this is what you have in your machine. And then you make a request to the model via the API, and then you get a response, right? With the next message and maybe some statistics, right? If the provider gives you this. So this box here means like one turn in our illustration here. It's just like this means one turn. And then you have to repeat this many times. So the idea is that I have the API call means like one request, one response. We send the prompt with the settings, right? Let's say, well, please, answer this, but just like you can limit, right? You can have set up some configuration that you don't want to have like a very long response. And then the model returns the message with some data like the token code counts and etc. Token here just means like subwords, right? Because usually we count it in words. So, but just for practical reasons, you can just like think about tokens are just words, how many words I'm getting back from the model. So then we repeat this process for every turn. And then at the end, in the final call, in the final request, you just send like this transcript without the context. And the judge is going to decide, right? We have like a specific information, right? We have a specific script saying that the judge needs to give us information like about the winner, right? If the judge doesn't, we actually are going to reprompt again until we get a response from the judge. Okay, I want to show you, this is like, I want to give you like a demonstration of this. So this is in this branch here in the GitHub. And you need to run this, you're gonna need like OpenAI API key. So you need credits to do this, but you can in principle also use exactly the same code with like open source models, right? But it's always very risky to do things in life, but let me try to do, because I guess you see.
Nayara, we have one question from
Yeah.
Backlash.
Oh, sure.
To what extent do you think say management will take the outcome of AI data fit on the future collider?
Exactly. This is very good question. Exactly, because this is, I think one important thing is that it should scale a lot, right? As I'm going to show in the results here, the conclusion, it's unclear for the scale that I'm doing, right? I'm doing like one model family, a very small setup, but I think as long as we get some interesting insights, and that's we include human in the loop, right? Because this is LLM, right? This is like debaters, LLM, and like also like the judge is a LLM. Because it's like a single person project, right? That's very hard to do. Like if I have more people, right, or more people that human in the loop, I guess this gets more serious, right? Yeah, but this is definitely a very good question, right? If people take this serious, well, if you have better outcomes than the real debates that people are doing, if you have some insights that people didn't figure out by themselves, I guess people will take this seriously. But for sure, you need to scale. It's not now. It's a very small experiment. Yeah. Thanks for the question. Let me just. Can you see this?
Yes.
I put. Can you see this? Yeah. Let me just run like something like this now. Let me run again this that was here. I just want to run. You can run this like in quiet mode, so you don't see anything, right? So you don't have like a. But I want to run the things like showing the communication of the API. Here's a super small debate, right? I just want to run like 2 turns, 1 repeat. I'm using like the random order and I'm attaching these 2 summaries, but I just want you to see these things running. Okay, it works. Let's see if the connection with OpenAI server is what is. Now we're like, you see, the debate starts. That's it. So here you have like a strategy 1 and strategy 2. And I call like this, I'm not calling P5 and FCC directly because I saw that the judge could be biased by this as well. So that's why I just at the end that I make the translation between what is strategy A, what strategy 1 and strategy 2. And here you see the discussion is going, then they have turn 2, I have the information about the tokens. We're gonna let this run in here and I just want to show like the configuration. Like you have, you can change the configuration in this code. Here, for instance, is the place you set your OpenAI key. And here you see I'm using this GPT forum mini. Like there's a very, like it's really not the state of the art of the model, right? Something small, but it's much cheap, right, than the others. That's the reason, basically the reason I'm using here, because to run like tests is much cheaper. And then we decide the prompt, you see are big prompts and the strategies. And here are basically the debaters, right? I have like set some configuration for the debaters, which model they are using. And I repeat, I always flip who starts the debate because I also realize that there is some bias this. So sometimes the FCC starts, sometimes the P5 starts, and so on. So let me see how long this is going to be quick because I did very. You see, the judge, you usually ask the judge to give an evaluation and say the winner was a strategy 2. You see some, and then we can keep going. We will have just four debates. So probably yeah, it's done. So you see the global statistics, you have like 4 matches. The strategy 2 won 3 times, strategy 1 1. This is like P5 and strategy 2 was FCC for this run. So you see in this case, FCC 1. That's basically this. And if you want to, okay, let me just put here, just compare like prices, like of the tokens here is you can access this in the OpenAI website. Of course, there are many other models. It's just the one that I'm using here because Oxford gave me credits for using this. So I'm using the 4.0 mini and you see like it's fairly cheap. This is like per million token. Okay, so per million, so it's a lot. So it's really a cheap model at this point. Okay, so let me put full screen again. Okay, so now let's discuss the measurements. How we gonna measure things here, right? Because it seems very okay, nice. You have these arguments, but how I need like concrete measurements. And this is like very hard part, right? Because it's basically inventing a way to measure these things. And there are 2 types of measurements that are fairly independent here. One is the position strain, right? Like the stance strain, or what is the best strategy? Is it strategy 1 or strategy 2? And the other thing that we want to measure is like the debater strain, right? What's the best debater? And the way to think about this is like if you have like a lawyer that's a very strong lawyer, but the cause is very weak. It's very bad cause. So you see, these two things are very independent, and we are trying to access this in an independent way as much as possible, right? And let's say from one side we have two strategies like the P5 and FCC or other proposals. And in the other side, how we're going to measure the debate strength is basically changing some parameters in the model, right? There are some configurations that we can change in the model, and we're trying to change them, like just fix everything else, change some configuration, and see if we see some effect in the model. And for this, I'm going to change something that's called temperature of the model. And this has nothing to do with the thermal bath temperature, and this is just a parameter, random parameter in your model, but I'm gonna give like more details now. What does it mean? So the temperature for LLM is just a sampling parameter. So remember that one call that we said before, that we make a request to the model, and then we give like this. We're gonna give like a set of parameters. One of the parameters is this T, and this is just basically a way to give like diverse, if you want something that's more diverse or less diverse, but you can in your reply, right? But you can make this more concrete, right? You can, so when you send a request to the model is going to predict a distribution over tokens, basically subwords. And this T is just like a ray scale parameter of your output, of your logits, right? So if you have a T, for instance, if your output is like Zi, and you have like a T that's very small, basically you see this becomes very sharp, right? So it means your response tends to be very repetitive and very deterministic. On the other hand, if you have like a T that's large, right, this is very broad distribution, and you have like a much more diverse, right, diverse reply. And you see, like in the limit that T goes to infinity, this is just an average, and in this case makes no sense, right? Because we don't want all the words to have the same probability. So the intuition here is just this temperature is just like a randomness for sampling, right? And of course, this depends a lot what you want, right? If you're more like, if you're evaluating some scientific text, probably want something that's more deterministic. If you want something more creative, probably want something that's more diverse. Depends. It's very empirical. And to visualize this, I found this this blog that is nice, that has this nice visualization, because you see you have the logits, right? Let's say the output of your neural network, and then you can just, okay, see, before I call Z, right? Z, but here they're calling Y. So you see, if I have a T that's low, I have like a very peaked distribution. So it is very likely that I'm going to reply with this word here. On the other hand, if I have a high temperature, I have a broad distribution, so it's not so likely anymore, right? I have all the other probabilities are also high. So T just means this. So what I did, I changed T, right? I changed the debaters based on the T. And how the matches are organized, right? How can we make sense of this, right? How the turns and the way I told you before. So I want to introduce this, given again an example. So we're gonna see like this toy mini tournament, just as illustration. And here we want to use something that's called ELO style ratings. Technically, we are doing this Bradley Terry model, but this is something not important for now. But you can really see this video, this YouTube video that's really, really good, right? They explain all this historical, I mean, why the names change and so on. So it's really, really useful. But probably you heard about this in the context of game tournaments and chess tournaments, like this English style rating, right? So the idea, the intuition is very simple. The intuition is just that we have like these pairwise matches, where each debater I has some score, right? Let's start with the same points, let's say like this. So, and the points here I'm calling like EI. So the probability that the I beats the J, right? The player I beats the player J in a debate is given by just the logistic function, right? And it's just this. And for instance, this delta E, the only thing that's important here are the difference, right? So the delta E here, the difference between the scores maps the win to the win probability. So if I have something that's delta, let's say delta E is equal 0.5, it means that, well, there is like 72% of chance that I is gonna beat E. I is gonna beat J, right? That's just a way to score things because we don't want only to count win rates, right? We really want to have here like a way to measure if we win from a stronger debate, this we get more points. So yeah, maybe that's the message here. So if you are beating a stronger debater, you're gonna get more points than if you're beating a weaker debater. That's what we want to evaluate in this system.
We have one question, Nayara, from Ramazan. He's asking, does the judge explain the reason for his decision?
Yes, very good, very good. Indeed, we have like I ask the judge, but this depends of your prompt, right? So in my prompt, I ask the judge to do some reasoning of the strong points, weaker points, and then indeed, let's see the one that I just run. For instance, you see, can you see again, right?
Yes.
The judge evaluation strategy to key insights, areas for improvement, the key strengths, areas for improvement overall, and then you say winner strategy too. So there is indeed some reasoning that yeah, that's a good point. And this can change a lot, right? You can remember that here I'm always I was very budget constrained, right? So I was limited the amount of tokens that I'm using. But even in this case, you see there is a long prompt, but you can, I mean, include many more things. You can say more specific things like, okay, strong points with respect to the physics case, with respect the construction, with respect, yeah. But yeah, indeed, you can. I ask the judge to basically in my prompt, I ask the judge to list the strong, like the strong points, the weaker points, the reasoning, and finally the conclusion. Yeah, that's a good question. Okay. So yeah, so with the systems, we're able to measure something that goes beyond just counting wins, right? And that's why people use this like, okay, in games, because indeed, just to recap, here we are able to get more points, right? If you're beating a stronger debater, you get more points than if you're beating a weaker debater. And just like to give an example from the case we want to study, right? The match could be strategy 1 versus a strategy 2. Then this could be like P5 versus FCC. And then debaters can have a list of debaters, ABC, and those debaters have like everything fixed except like the temperature parameter. That's it. Let me show you some results. Let's see the time. Yeah, let me show some results that are like work in progress regarding this. So just to give you, I mean, the context here, I'm using GPT-4o Mini, like this small model. And the reason for this is because it's cheap and also it has very good controllability. So it's very easy to customize in the sense that I can change temperature, I can change max tokens, I can change a lot of things. And the newer models, sometimes you cannot do this. They don't allow you to do this customization. Of course, if you're going to use an open model, probably you're going to have much more, I mean, the ability to customize will be much bigger. So it's also good by using an open model. The results I'm going to show you, they have 72 matches, right? So I do like 3 debaters, like ABC, cross-play, and repeat 6 times in both directions, every time one start the debate. And again, right, the cost, they scale with tokens. So, and let me, just to give you an idea what I mean by tokens, one word corresponds to about 1.5 tokens. Okay, that's more or less the counting. So you see in that table, usually people count now in millions of tokens. And this was very expensive. It's getting much cheaper now to run this type of debate here, like with 72 matches, that long debates, I spend less than $1, right, per 72 matches. And I have to thank Oxford for giving me the credits for this. But in principle, people should use other models, like not only OpenAI models, and also other, like also try this with open models as well. Another information is that, okay, we test these two measurements, right? Both like position strength and the beta strength. And I test some other thing beyond temperature that's called best of n. I'm not going to discuss here, but the idea of best of n is just I ask to the model any times the same thing, and then I just select what's the best answer using some condition. But the important point here is that we fix everything, right? The model, the prompts, the judge, and we just change one parameter. So that's why we want to see how I mean, with the variance of the debaters are just like based on one fixed parameter that we changed, like the temperature, as we discussed earlier. So this is the one plot. So if you have here the win rate, and here basically this best of n scenario and the temperature scenario that we discussed. And here we have P5 and FCC, and you see like the FCC is winning, right? But this very small margin, right? The intervals overlap broadly, so it's not like a definitive. I cannot say, okay, there is a winner, right? Apart from all the problems and limitations that we said before, I mean, there is still not clear in this case what's the winner. Now, if I want to measure like the beta strength, so let's understand this plot carefully. So I have like temperature here, right? T 0.3, 0.7, T1, and here I have the ELO. So if I have positive, it's better, right? Larger ELO, it's better. So you see, right? Let's look at the marker here. There is no clear trend, right? There is even no clear trend. If I'm increasing, let's say, the temperature, it's going here, so it could indicate that, okay, if I have like a larger temperature, I'm more creative, so maybe like I'm a better debater. But it's not clear because the largest temperature, that's one that is here, is actually it's smaller. So again, the overlap, I mean, the intervals overlap broadly, so there is no clear trend, at least for this scale, right? It's a very, very small scale. So I mean, let me just start concluding, because we have several conclusions. So here the idea was to really pioneer AI-driven debate, and that in some way can give you like a organize and help experts, right, in deliberation. For this scale that's quite small, and this benchmark that I'm just comparing two strategies, there is no clear trend, right? As you saw in the plots, right? You can say, okay, FCC is winning, but just by a small margin. Here, the temperature is also does not like change much. Maybe if I make like something very dramatic here, some change, and then there is a difference. But I want to keep like the temperature in a reasonable, I mean, under some reasonable interval. And so the limitations we discussed already, like, well, I'm using a single question tournaments. I'm just using one model family, and one LLM judge, right? Some obvious extensions can be, we need to rejudging, right? The transcripts with stronger and multiple judges, right? You can have like much more judges, right? You can compare, right, additional model families. I mean, there are a lot of obvious things, extensions of this. And again, this is like a prototype, but the broader scope is clear, right? We want to introduce multi-question policies, integrate tools. For instance, LLM can run like very small like simulations already, like of not so heavy simulations, but the small Python scripts that LLM can do the experiment itself. We can include very important human in the loop here, right? Like a consultancy, right, during this iteration. Like, as I said, there was a in the paper, in the AI safety paper that I showed at the beginning, they have this scenario where the judge can interact during the debate, right? Could be like a human interaction as well, right? There is a debate, the human can read the transcript and say something. And also, of course, this goes beyond the particle physics, right? It's like you can apply this for other domains as well. So yeah, I was asked to give some before. Well, I'm gonna open for questions, but I was asked to give some information about my background before we conclude. So I'm from Brazil. I was born and raised in Brazil, in Volta Redonda. That's a city in Rio de Janeiro, the state. And like this is like a picture of the city. The name is very weird because in Portuguese it would mean like a round circle, so it's kind of redundancy the name, but it's because of this river. And I did my PhD in São Paulo, at the University of São Paulo, and from there I moved to different places. I started in AI because I want to get inspiration to my work in physics, and then I realized there were so many open questions in AI as well. But when I started, indeed, like a few years, well, many years ago in physics, I would never expect that I would have all this opportunity to meet so many nice people, so like and do some like change the field different ways. So it was really like adventure, and I think curiosity is really a good guide, and it helped me a lot. And also science is indeed transformative, right? I think if we do these things together, I think we are much stronger, right? Yeah, that's it. Thank you very much. And please ask questions.
Thank you so much, Nayara. That was really lovely talk, really interesting. So we've already had some questions. I wonder, there's lots of clapping going on. Thanks, everyone. Is there any more questions that you'd like to ask?
Oh, the job to explain the reason is there. Oh, okay, there's.
So maybe I can ask a question.
Yeah, sure.
Nayara, what do you think if like AI agent can effectively weight the conflicting, evidence and indicate like confidence level of the scientific debates?
You mean if what? Sorry, what do you
Like
mean if?
AI agents, what do you think? Can they like effectively weight some conflicting evidence or some level of scientific debates?
Yes, I think it a bit. This is like also a bit related with the other question, right? That it's like that CERN is going to take this seriously. I think if we have some insight, right, that comes from this, then people have to take seriously, right? Because then okay, why you didn't figure out yourself, right? The agent just told you. I mean, so I think this is gonna be like my general expectation is that physicists are very skeptical. That's something that's very interesting because if I talk with both communities, like I talk with like people that do like that are basically AI researchers and I don't know, AI alignment people. And when I explain the problem to them, right? Well, we have this debate now in physics, in high energy physics. They say, of course, one should do this. This is obvious, right? And then when I talk with people in physics, they say, this is science fiction, completely science fiction. So I think there is no like, I don't know, something in the middle I think could be good. But I agree with you. I think people are skeptical and they should be skeptical because we don't know, right? We're not gonna give it up, right? Like they give you like, okay, now AI do everything. I think human in the loop is important, but I think one way to put that people would be happier or like convinced is just show something that they didn't figure out. And this happened already in other fields, right? Especially in fields that like researching machine learning, right? People found other algorithms just that they were just found by the agent and not by the machine learning researchers. In this case, people just they cannot say anything, right? The AI figure out something that they didn't. But you see, like our question is very complex because it's not like a yes or no. Like it's not like prove a theorem, right? That we can verify if it's right, right? Now it's like it's very complex, right? It's very It's difficult.
It's
Yeah.
like the idea of thinking out of the box is not, implemented in any models yet, but it's the capability of human being that can think a bit beyond.
Yeah, I think that there is a limitation in the models now, in the sense that they are very good in varied domains, but they do not cross much, right? They do not have this, like, usually breakthroughs happen when people go to the boundaries of the
Yeah,
knowledge,
exactly.
and then this is something I know that people are start training models like this, with, like, to have more interdisciplinarity, right? Because this is basically where the breakthrough happen, right? But they are very good, let's say, in very specific area of science, but not like in the boundaries, right? When you connect with the areas.
Yeah, I was like always wondering if one day we could train LLM with, for example, the previous knowledge of human being. Like, I was wondering, like, if, for example, this LLM had the capability to know, for example, Riemannian curvature and some other knowledge before, for example, Einstein discovered the curvature of space-time. Could it also get to that level that, bring a new science this way, like find this complex connection that human beings are capable of?
Yeah, I guess, like in our kind of science, right? Like, say, theoretical physics and other things, it's more complicated because we have many things that we want to add, right? We want the thing to be elegant. We want the thing to be right. We have other, but you see, for math, it's already doing, right. Was already able to prove, like, theorems that are quite simple things, right? They're very simple, but they're like in principle new. So this is already happening, like in math. Right? In math, there are already examples of proving new theorems, very simple ones, not something that it's like not publish a paper because of this new math result, but something that PhD level math.
Yeah.
Yeah. So, but math, you see, in this case, math, it's easier because it's verifiable, right? In our case, it's like, what we consider good, right? What we physicists, theoretical physicists, are complicated.
Yeah.
Are
We are
complicated.
more have using intuition than also in the same line along with the logic, which is a bit difficult in mathematics to find. They
Yeah.
have more
No.
of their own structure.
Yeah, that's very good question indeed. But I think there is no obstruction, right? There is nothing like that say, okay, this cannot happen, right? So it might happen. I don't know. Could be soon. Could be in a few years. But yeah.
Okay, thank you very much, Nayara. I see there is no question here, and our next talk will start after the lunch break. So if you have any other question, I will send the email of Nayara. You can email her. And thank you very much again, Nayara, for accepting and coming and giving us the talk. It was really great and very, different perspectives towards particle physics. And
Yeah.
hope to
Thank
see
you
you
very
again.
much. Yeah. Thank you. I was expected to be very exotic indeed, right? But I hope you guys enjoy it. Yeah. Thank you
Yeah,
very
it was
much for the
really cool.
invitation.
Thank you.
Thank you.